So let's just wait for it to open. Um, music. All right. $20. Let me just create a file. Hello, DJ. You got 20 seconds to be on the leaderboard. More like 14 sometimes. Hoof it. You all arrive at a lava production facility. Vaguely remember this one. On a floating island in the sky. As the others begin to search the massive industrial complex, you feel a small nose boop your leg and look down to discover a reindeer wearing a hard hat. The reindeer is holding a book titled Lava Island Hiking Guide. I remember this island year. That was a cool map because it was like it reminded me of Mario RPG, where it's just like a series of islands floating around. However, when you open the book, you discover that most of it seems to have been scorched by lava. As you're about to ask how you can help, the reindeer brings you a blank topographic map. Oh, we got a Wikipedia link. Contours and that. Of the surrounding area. You puzzle input and looks up at you excitedly. Perhaps you can fill in the missing hiking trails. The topographic map indicates the height at each position using a scale from 0 to 9. Based on unscorched scraps of the book, you determine that a good hiking trail is as long as possible and has an even, gradual uphill slope. For all practical purposes, this means that a hiking trail is any path that starts at height 0, ends at height 9, and always increases by a height of exactly 1 at each step. Well, that's not going to be a very long hiking trail, is it then? It's going to be just 9 steps. With this map. Hiking trails never include diagonal steps. You look up from the map and notice that the reindeer has helpfully begun to construct a small pile of pencils, markers, rulers, compasses, stickers, and other equipment you might need to update the map with hiking trails. Oh, we're probably going to map out a lot of hiking trails. The trail head is any position that starts 1 or more hiking trails. Here, these positions will always have height 0. Assembling more fragments of pages, you establish that a trailhead score is the number of 9 height positions reachable from that trailhead via a hiking trail. Alright, I get it. In the above example, the single trailhead in the top left corner has a score of 1 because it can reach a single 9. This trailhead has a score of 2. Alright. Yep, I get it. And then we add the scores of the trailheads. A protractor. Nice, okay. Alright, so this is just breadth first search, really. So that is sure a giant block of numbers, yeah. It's 53 by 53, it seems. All right, so we had similar grid stuff in yesterday's. No, 8. Yeah, so let's reuse a bit of code from 8. Let's say that. It would be interesting if it was somehow a prime number. 53. It is a prime number, isn't it? Except it's not 53, it's 52. Because this is starting from 1. Oh no, it is 53. It is 53. Yes, this is starting from 1. Don't know if that's relevant. Probably not. Guess he just chose this number. So so that gets the grid. So we want for I in range and for J in range M. Hang on. So let's just create our we'll do DFS here. So DFS is going to find all the return a list of all the locations. We don't even need to return the list. We just need the number. We want to find how many locations are reachable from this start of height 9. Okay. So Q equals Q, pop start on the Q. All right, so while Q current equals Q dot pop, start. Wait, just to be clear, it's number of unique destinations, right? There could be 2 trails which reach the same place. Yeah, it's the number of positions reachable. Okay. All right, so should we just do peaks? That's what we'll call them, peaks. Does not need to be unique though. Well, we're counting unique positions. So if multiple hiking trails reach a position, that counts as 1. So actually, we probably want a set here. So that we don't double count. Peaks equals set. Alright, so while Q current equals Q dot pops. Nope, Q dot pop. We take something off the Q. Because we're always going up, we're never actually going to revisit past nodes, so we don't need a visited set. So we can say, if Grid. Hey, I got a scammer friend invite in Discord. It's been a while since that happened. Oh, really? Get one every month or so. Oh, we also want to copy the pause method, I suppose. Inbounds would be useful. So that gives us our pause class. So if grid current.i current.j is 9. Should we make these ints so that we can actually compare them as ints? Grid.append int x for x in line.strip. So it is 9. Peaks dot add current. So we found a peak. We don't even need to do this. We just have to not add 9s in the first place, so we can yeah, don't bother doing this. We'll just leave it till later. Find neighbors. Or let's create a get neighbors class here. For delta in pause 0, 1, pause 0, -1, pause 1, 0, pause -1, 0, return self plus delta, so that's the neighbor. And we can check inbounds as well, so... Or should we just do that here? Also, that's wrong. We don't return. We yield. Let's say we yield. If self... If it's inbounds, self plus delta dot is inbounds, yield it. Just notice your IDE tells you the parent functions of the code you're writing. What are you referring to? At the bottom. Oh yeah, I never even looked at that bar there. Yeah, that's helpful. So for neighbor in current.get neighbors. So we've already done the inbounds check. So we can say if grid neighbor.i neighbor.j really useful and a complex thing. Yeah, it's useful to see the context of a line. I think I do actually want a visited set here. Visited equals set. So rq current equals q.pop. We've visited this. Right. So for each neighbor, if grid neighbor is equals 1 plus grid current.i current.j if neighbor not in visited and well, let's just check if it's a peak. Or, okay, if it's not in visited. We'll check if it's a peak. If equals 9, peaks dot add neighbor. Alright, now if it's not visited, then we'll say else if, because we don't actually want to add peaks to the list. There's not going to be any neighbors. If it's not in visited, we put it on the queue. Queue dot end neighbor, and we call it visited. No, because we didn't. We'll call it visited here. If it was if it was Dijkstra's or something, we would have to call it visited only when we pop it, because you use lazy what's it called, evaluation, where you can get shorter distances appearing. Everything's distance 1, so we'll do it here. Visited.add neighbor. And then if this is all correct, I don't know, we'll see, we return length of peaks. So we want if grid I j equals 0, result plus equal DFS of this starting point. So it's going to count how many unique peaks. Okay. Print result. 644. Do you really think I would have written DFS correct on the first try? Apparently so. Part 2. The reindeer spends a few minutes reviewing your hiking trail map before realizing something, disappearing for a few minutes and finally returning with yet another slightly charred piece of paper. The paper describes a second way to measure a trailhead called its rating. The trailhead's rating is the number of distinct hiking trails which begin at that trailhead. For example, the above map has a single trailhead. Its rating is 3 because there are exactly 3 distinct hiking trails which begin at that position. Here is a map containing a single trailhead with a rating 13. Seven, 8, 9. So they can arrive at the same place, but there'll be 2 different trails. Okay, should be able to just adjust the method, but it's... Okay, let's see. So we'll call this DFS1. Alright, I want to change this now. Slightly. DFS2. So we don't care... Wait, is it still have to reach 9? Yes, we do. Yeah, okay. So... we don't need to store the peaks. Alright, so I think what we want to do here is remove this visited set, so we actually repeat past nodes if we have visited them via a different path. So we change this, we just say... In fact, take all this out. So if this is a valid next step, then q dot append neighbor. Don't do that. Here we say if it's 9, rating plus equal 1. So basically every time we arrive at a 9, we add 1 to the rating. And we may arrive at a 9 via different paths, but because we're not keeping a visited set, we are actually duplicating visiting a node, but we should hit the node the right number of times, because every time we follow a different path to get to that node, we'll open. Oh, wait. Yes, that's right. And because we're only going uphill, we avoid going back downhill. So, let's try this then. See, if we didn't have this uphill thing, if it had to just be arbitrary, then that would be difficult, because if we remove the visited set, we could end up going back to a node we've been before. So we would actually have to keep a stack of the path we've been to so far. Yeah, it might be a bit more complicated, but we'll try this. So we're summing up the ratings. 1366. Don't know if my... Yeah, the logic's right. In fact, that DFS was even simpler than before because I just removed the visited set, so... It just seemed like it was going to be harder than it actually was. But this is actually basic DFS. We just do DFS, find all destinations, put them in a set to remove non-unique peaks, and we just add one for every path that led us there. So it's actually simpler than what you would normally do for DFS. Normally for DFS, you would purposely avoid revisiting nodes you've visited before. Here, we are allowing that as long as it's, you know, it's always going uphill, because two paths can lead to the same place. I mean, that's probably the... If anyone's gonna make a mistake on this, the most common mistake will probably be that they don't account for multiple paths reaching the same point. And just count that as one. And I mean, my code can actually be much simpler now, because I don't need to actually... This is the DFS. We can actually just say, there's just one DFS method. DFS rating and peaks is both there, and we say blah, 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 blah. If it's 9, rating we add 1, peaks to add. So for part 1, this is less efficient because we don't actually need to be revisiting nodes for part 1, but whatever, it's instant either way. Peaks.add, and then we return. What was the term they used? Ratings, scores. Okay. Okay, so we return the length of peaks and the rating. And then down here we've got score, rating equals 0. For iron range and for Jake with them, blah 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 blah. To say SR equals DFS score plus equal S, rating plus equal R, print score, print rating. Should just be able to just do it in one go like that. Six four four 1366. Six there. Okay. That's it. That's... We don't even need sub. I'm just trying to simplify my code as much as possible. Add is fine. Get neighbors is... Yeah, that's nice and compact. Yeah, this is a pretty compact piece of code here. Ratings. It's fine. Yeah, I mean, I would say if someone's learning DFS for the first time, this would actually be a very good problem for them, because not only would it have them write DFS, but it also have them understand DFS, because they know when they should or shouldn't be keeping track of past nodes to avoid them. So this could be exponential in the worst time, because with a really bad map, you could have a huge number of paths that could... Let's say hiking trails, you're allowed to go on level ground, and the whole map was like zeros. Or no, you got like 1 0, and then you got a whole sea of ones, and then 2, 3, 4, 5, 6, 7, 8, 9. Then it's like massively exponential. You wouldn't be able to even calculate that, because there'd be so many parts where you'd just walk around on the ones. But if you just add in that visited set, you would stop visiting past ones and you would just pick one path. Doesn't matter how far it is, and you would get to 9. And then you would also pick other paths, but the point is they would all be crossing out nodes from the visited set, so you wouldn't revisit those nodes again. That's how you make it linear in the size of the map. Now, but even in that example, there's probably a way to make this calculate the rating in linear time if you were to just keep track of the breadth, the breadth at each step. Like, you're not going down every path, but instead you're storing account for how many paths lead to this node. Then to get to the next node, you're just multiplying this number by the number of steps you take to get to this node. So yeah, it could be done even for nasty graphs. But this height restriction forces the path to always be 9 steps, so it doesn't matter. So that made it really easy, actually. Okay. Well, this is the first time I did one on time, as in, like, the thing just opened, so in this case we can see how I did on the leaderboard. Well, how did I do? It doesn't show me. I have to go to Oh, no, we have to go to 10. Well, it doesn't show me here. Okay, fine. We need to go to... stats? I don't even know my time. Like 28 minutes. I'm sure there is a... Unless they've removed it, I'm sure there is something which tells you exactly how long it took you to solve it. I think they've removed it. I mean, I can look at my... Oh, personal times, there we are. "25 minutes, 45. Yeah, that's the only day I actually really started on time, so the rest were all like... It would be nice if they had a thing for just calculate your time since the moment you open the problem. Because that would just be a personal thing, because obviously people could cheat, so it's not a competitive thing, but it would... If I'm opening it, then it would give me an idea of how long it took me to solve the problem. In the top 5k? Oh yeah, that's the rank. Well, we've got a lot of people these days. So that's 206,000 solved part 1. Oh, both parts of 1. Do we have a stat somewhere saying how many people participated full stop anywhere? Because they might have just done like part 1 of 6 or something. Stats. Don't think we can actually get that from this. So it's going to be more than those two numbers added together. That's a lot of people. That's insane. What was it last year? Around the same, but yeah, this is accumulating because people are still doing these to this day. So this is over the past year. But yeah, in only 10 days we already have 200,000. But yeah, I mean, these past years, like, people... So 2015, I don't know if people actually... Many people actually going back and doing it. But 100,000, that's still pretty high. Like, when Eric first launched this in 2015, it was just something he was expecting maybe 100 people. He just shared it amongst his friends, I think, and he says, hey, I'm making this cool thing. For us to do a bunch of puzzles, and it just blew up. But I mean, it wasn't anywhere near this many. It was maybe about 1,000 or so, which, like, at the time that was blowing up. So he had to scale up because his servers were not expecting that many people. I mean, you can go watch a talk that he did at Google about his experience making this site. It's a pretty good talk. Oh, he did a new one recently, I think. I'll have to go watch that. He did a new talk just... I think the video only released like a few days ago about Advent of Code, how he's been running it in general, and the challenges he faced. I wonder if he now talks about AI and what he did or didn't do about AI. I mean, there's not much he can do, but he may have done some steps. Like, I know that Eric really tries to... Like, he popped into my chat once or twice in the past, and I even, at the time, I pointed out some puzzle sites I use, like Coding Game, and then he said, that's nice, but I don't want to look at any of those sites, because he doesn't look at any puzzle sites ever, because he wants these puzzles to be completely unique, and not repeats of puzzles from other sites. So he flat out just doesn't look at puzzle sites to avoid accidentally copying problems. And obviously, the paradigms that are involved are still going to be repeats of some past problems, because it's you know, DFS and things like that will always show themselves over and over again, even if you think you're constructing a completely unique problem. But nevertheless, it's still the problems are pretty unique and not easily Googleable, because in some cases, like, there really hasn't been especially the int code stuff, where, and that happened heavily in 2019. Like, that was very unique. It was the even numbers, wasn't it? Or odd numbers. Yeah. That was a very unique thing, and that was his own creation. By the end of it, we had developed an int code that could basically play a choose-your-own-adventure game. That was pretty cool. I don't think I used any code for that. I ended up just playing the game. You can't really automate the solution of this. But that does mean AI could not play this. Like, AI could not solve this. This is un-AI-able. Well, if you gave AI prompt access to the game, then I suppose the AI could play the game, but it would have to wait for each prompt to be... So it definitely couldn't be done in 14 seconds, but you could have the AI analyze each result of moving and stuff and figure out where to go. You do have to restart the game sometimes if you die, for example. So yeah, AI probably could solve this, but it would have to do a sequence of steps. AI could not produce one single script which could give you the answer for this. AI would have to actually play the game, so it's still, in some ways, less work just to do it yourself, but... Okay. Cool. So... let me go back to 2024. Leaderboards, private leaderboards. I might actually be early today. We've got two people. Solved them. Umara is keeping up. That's cool. And Captain Coda. Smab UK is probably working on it soon. Is Captain Coda himself actually... Yeah, I think he's on holiday or something, so he's probably, these few days, he's not going to do them. I wonder if Mara's still doing this all with Game Maker? Yeah, he said he is. That's pretty impressive, because some of these problems probably don't lend well to Game Maker, but at the end of the day, it's a language, so yeah, maybe it's fine. You can just write scripts by themselves and it'll look like C# code or whatever. Oh, Temporalix Thanks for the raid. I just finished. Yeah, I was just talking about uh the site in general, and did you just do day 10? This was I thought it was an easy problem, as long as you know pathfinding. I mean, I just did depth first search, the most basic version. I didn't even use like a double-ended queue or anything. I just used a Python list, um, and it was pretty fast. And there were no real catches. I was expecting catches, but I mean the condition of going up by one each step. Like I thought he would at least relax it so it's like you could go level or up. In which case, if he throws a bunch of like, if you're standing on two and there's a bunch of other twos, then there's more paths you could follow where you go on level ground and then go up. But no, this condition means that every path is exactly length 9, so it's actually pretty pretty easy. Yeah, so yeah, we haven't really had any major challenging pathfinding problem. I think what I did was depth first, right? Yeah, depth first is usually the easiest to just throw together because just throwing things on a stack. Accidentally wrote correct code for part 2 first, didn't check for same 9. Ah, so your count, okay, yeah, your count would have been, um, and you weren't like avoiding revisiting nodes, right? Because that would technically speed up part 1, but you'd still get the correct answer if you left that out. Like the proper way to do depth first search is to not revisit nodes. Because that makes it exponential in the worst case. But yeah, for part 2, if you relax the condition and actually do revisit nodes, then you're getting all the paths. I did BFS. Yeah, it should just be the well, yeah, BFS actually sort of innately avoids oh no, BFS will just get the same result, won't it? It wouldn't really make much difference. So did you use like a queue data structure for that? If I was doing BFS, I suppose we would use from queue import DQ. I can never remember how to spell these things. Something like that. I don't think it's even in queue. Is it from heap something? Heap queue? I don't know. Collections. Ah, it's in collections. Okay. Collections import DQ. Yeah. So I could have just replaced that. Should just give the same result. Yep. Pretty straightforward. Okay, so I don't know. Let's see if anyone else is doing this. Yours looks more succinct. Well, at first I had 2 different depth first searches, but then after I finished the problem, I then kind of just tied them together as one, because you can do the score and rating in like one pass. Larry. NY. Python. Okay, he's doing Python.
you'll get there. Like I said, I mean, I also say this.
Is he finished? Yes, well, see if anyone's still doing it. Ront TV. Okay. Let's go raid Ront TV then. All right. All right, thank you all for watching. I started this one bang on time today. That probably won't be the case for most days. Maybe the very last day. So the next couple of days, it depends what I'm doing. I might be busy. I don't know if I'll even be able to do it. At the very least, if I can't find the time to do it, I'll record it offline and upload it to YouTube, so you can always find the video there, should you want to see it. All right, thanks for watching. See you next time. Bye-bye.